Where are the moons? Where are the rings? Let us begin with two simple statements based on mere observational evidence. All the gaseous planets of the solar system, Jupiter, Saturn, Uranus, and Neptune, have developed a ring system, while the terrestrial-type planets, Mercury, Venus, Earth, and Mars, have not. All the gaseous planets possess entire legions of natural satellites, while the terrestrial planets are almost totally devoid of them. Yet smaller, large, solid, or gaseous, all planets in our planetary system have had a common origin. Why can't Earth boast of a beautiful ring system? And why are Venus and Mercury completely devoid of moons in their sky? What cosmic law commands or forbids this? There are a lot of things that differentiate the planets. Each of them is unique in size, constitute elements, appearance, and color. But to the eyes of a careful observer, it cannot escape the fact that there are two large, immediately recognizable groups, those of rocky planets and gas giants. There are in fact 8 planets in our planetary system. Mercury, Venus, Earth, and Mars are small and rocky, while Jupiter, Saturn, Uranus, and Neptune are giants, gaseous, or icy. The first 4 are extremely different from the others, not only in appearance, but also in composition, evolutionary history, and formation, leading to a natural distinction between the inner and outer solar system. Since all planets, both outer and inner, formed from the same disk of dust and gas that surrounded the Sun, the reasons for such differentiation must be answered somewhere in the history of their formation. But when did this separation occur, and why? The most likely explanation is that there was an empty space in the disk that separated the inner from the outer disk. Such a structure must have been in the main asteroid belt, but it is not yet clear whether the gap may have formed because of Jupiter's gravitational action or because of the Sun's gravitational action. What is certain, however, is that through this dividing belt passes the so-called frost line, which is the dividing line between the outer region of the solar system, where water is found only in the form of ice, and the inner region, where water has instead been volatilized by the Sun's heat. However, things have turned out that boundary has enshrined the clear separation between the inner planets, which are denser and smaller than the outer planets, and specially endowed with a solid surface. There are, however, 2 peculiarities that jump out at you. None of the inner planets possess rings, whereas the totality of the outer planets do, and in addition, the inner planets are virtually devoid of natural satellites. Out of a total of 221 satellites cataloged so far, 218 belong to the outer solar system and only 3 to the inner one. Of course, it makes quite an impression to hear that all outer planets possess rings. To hear such a statement, an astronomy enthusiast left over from the 1970s would jump on his chair and shout, "What are you talking about? Only Saturn has rings." And indeed, until 1977, school books reported that there was only one planet in the solar system that could claim the title Lord of the Rings: Saturn. In fact, Saturn's rings are the most extensive ring system, so they have been known to exist for quite some time. Galileo Galilei first observed them in 1610, but they were not recognized as such until 1655, with the observations of Christian Huygens. And we have known for several decades now that they consist mainly of water ice, with the individual particles varying in size from micrometers to meters. But on March 10, 1977, there was the first small revolution. On that day, some astronomers aboard the Kuiper Airborne Observatory, an aircraft equipped for high-altitude infrared observations with a 91-centimeter diameter telescope, were tracking the occultation of a star by Uranus to study the planet's atmosphere. But when they analyzed their observations, they discovered that the star had briefly disappeared 5 times before and after the occultation by the planet, a phenomenon that can only be explained by the presence of very thin rings. Such a ring system was later actually photographed by the Voyager 2 probe that passed near Uranus in 1986. Just 2 years later, on March 5, 1979, it was Jupiter's turn to be visited, this time by Voyager 1, and again there was the surprise of discovering a ring system, albeit a very faint one. To get to the question of whether the 4th and final gas giant, namely Neptune, was also surrounded by rings, one had to wait until August 25, 1989, when Voyager 2 passed within 5,000 kilometers of the planet's atmosphere, revealing the existence of a system of faint, dark rings similar to those of Uranus. Basically, in a period of 12 years, from 1977 to 1989, the ring lords went from 1 to 4, which has confronted the astronomical community with a couple of big questions. How are these structures formed? Are they the inevitable remnant of the formation process of the outer planets, and thus were born with them? Or did they form accidentally due to different causes? Why do only the outer planets form rings? Hang on a sec, guys, before we continue. Be sure to join the Insane Curiosity channel. Click on the bell. You will help us to make products of even higher quality. It seems unbelievable, but at present, for the first question, there is still no agreed answer. Apparently, however, everything seems to be governed by the so-called Roche limit. You'll certainly remember it. The Roche limit indicates the minimum distance at which a satellite can orbit a planet without being fragmented by its tidal forces. An object that crossed this limit would in fact experience a much stronger gravitational pull on the hemisphere looking toward the planet than that experienced by the farther hemisphere. The tidal forces would be so intense that they would eventually overcome the intrinsic gravity of the smaller body, shattering it. If the planet and the satellite have the same density, the Roche limit is worth about 2.42 times the planet's radius. Within this limit, a satellite of discrete size will then be deformed and then disintegrated, while very small satellites, those able to withstand gravitational stresses by their internal cohesive force, will be able to continue orbiting without problems. Then there is another thing. Within a disk of fragments surrounding a forming planet, matter located beyond the Roche boundary can aggregate to form satellites, while in an area closer to the planet's tidal forces prevent the formation of any satellites. But just so you can get an idea of the distances involved, here is what the limit is theoretically worth for each of the gas giants. Jupiter, 175,000 kilometers. Saturn, 147,000 kilometers. Uranus, 62,000 kilometers. Neptune, 59,000 kilometers. Well, from this data, it will be very instructive to verify, if you feel like it, that all the rings of the planets in the solar system are within the Roche limit of their planet. And this is a very strong clue indeed. So much so that based on this finding, astronomers have formulated two hypotheses that could explain the formation of the rings. The first is this. The gas giants, as is known, form from the aggregation of gas and ice contained in the disk of materials that envelop the Sun. In turn, the forming planets were also surrounded by their own accretion disk. Above the Roche limit, particles from these disks aggregated to form satellites. Below the limit, on the other hand, tidal forces prevented aggregation, and the remaining material was then confined in more or less thin rings by the action of the so-called and very small shepherd moons. Instead, the second hypothesis ventures that it may have gone another way. Once each planet had completed the formation of its satellites using all the material in the disk, one or more of them may have slipped for some reason, as is happening to Phobos, the satellite of Mars, below the Roche boundary, where, torn apart by tidal forces, it would give rise to one or more rings. An accident in the planetary system could have occurred at any time in its history, even very recently. All this would then lead us to think that it is quite normal for a gas giant to develop its own ring system sooner or later. Even though, however, the second question remains to be answered. Why did only the outer planets form rings? If the hypothesis of ring formation due to the disintegration of a satellite were true, then this would also explain why the inner planets are completely devoid of them. Indeed, the lack of rings seems to be related to the lack of satellites. Let's see how. The main fact is that the giant planets were formed in a very different environment from that of the terrestrial planets. The larger volume of space available and less gravitational interference from the Sun allowed Jupiter, Saturn, Uranus, and Neptune to form as miniature solar systems. In addition, it was much colder in the outer solar system, and all the water there existed only in the form of ice, which allowed the planets to acquire mass in large quantities very quickly. In contrast, the terrestrial planets formed much closer to the Sun, with much less material around them since the water had been turned into vapor and dispersed by the solar veto. and they grew slowly by accretion of small rocky planetesimals, without ever becoming massive enough to form their own disk of gas and dust. No accretion disks then, and therefore no satellites ever had a chance to form around Mercury, Venus, Earth, and Mars. Sure, Earth has the Moon and Mars has Phobos and Deimos, but both cases are exceptions that have nothing to do with a generalized formative process. Our Moon, is formed by the occasional impact of Earth with a Mars-sized planetoid. A ring of dust and rocks also formed as a result of the impact, but in a few thousand years, or even in a few hours as one recent theory would have it, it thickened to give birth to our satellite. Similarly, the Mars satellites are merely the result of the cause of gravitational capture of two asteroids by the red planet. Nothing like those veritable satellite factories that are the outer giant planets. But wait a minute, we just said the Earth, too, was for a short time surrounded by a ring system. But then, why did they not last? The answer lies in the fact that most likely the ring formed far outside the Earth's Roche boundary, which is worth about 18,000 kilometers. If it had formed inside instead, the orbiting debris would never have been able to coalesce. And it is curious to note that Mars will also experience the thrill of seeing itself surrounded by a system of rings. It will happen in the not-so-distant future when Phobos, which due to tidal friction is also getting closer and closer to the red planet, will exceed the Roche limit and break up into a dusting of rings. Rings which will be very short-lived, however, in a slow fallout on the planet or scattered by the solar wind, which at the distance of Mars still blows very strongly.